something called proper rational function. Okay. A rational function f of x is a ratio between two polynomials. The numerator, let's call the numerator p of x and denominator q of x. And p of x is a polynomial of certain degree, and q of x is a polynomial of another degree. We're going to say that f of x is a proper rational function if the degree of p of x is less than the degree of q of x. Okay? F of x is a proper rational function if the degree of p of x is less than degree of q of x. That's the definition. Now, what happens if a function is not proper? Then what we can do long division to write the rational function as a polynomial plus a remainder. Let me demonstrate this. So let's write another comment. If, let's say, f of x, again, equal the ratio of two polynomial p over q, is not proper, and instead of writing proper rational function, just say not proper, what we do in this case, then we use long division to obtain the following. Okay. For instance, we're going to say that f of x, we're going to take p and divide by q, and the result, we're going to have a polynomial, let's call it s, and the remainder will be r over q, where r over q is proper. Let me give you quickly one example, and then I'll talk about the technique. I'll write about the technique. Since I won't be in class on Tuesday, I'll write about the technique in general. Okay? You'll see that there are 3 steps and 4 cases. But just the first preliminary example will demonstrate what comes ahead. So we need to evaluate the integral of x cubed plus x over x minus 1 dx, like so. Okay? And the first thing we observe that the degree of the numerator is greater than the degree of the denominator. So this particular function is not proper. So observe that x cubed plus x over x minus 1 is not proper. So here, the art of long division. We're going to divide, and we're going to say that, let's see how it works out. We're going to divide x cubed plus x by x minus 1. Of course, we need to have x squared, right? So we multiply, get x cubed minus x. We subtract minus x squared. Okay, so we subtract, and we have positive x squared plus x. So we need to multiply, we need to add plus x here on top. So here we have x squared minus x. Again we subtract, and we have 2x. So 2x is the remainder. So the result would be x squared plus x plus 2x over x minus 1. So this is s, x squared plus x is s, and r over q is 2x over x minus 1, where 2x over x minus 1 is a proper rational function. You have a question?
How do you get x squared plus x after the first subtraction?
X squared times x is x cubed, x squared times negative 1 is negative x squared. You subtract, and you have x cubed minus x cubed, that's 0. And then you have nothing plus x squared, because double negative. And then you have the x. So the next row is x squared plus x. See?
How is that x become nothing?
There is no x squared term in between the x cubed and the x.
Oh, yeah, because there's an invisible x squared.
Right. You are missing one.
Right, I forgot to add that.
All right. So now we're going to say that the integral, let's wrap it up. So now the integral of x cubed plus x over x minus 1 dx looks like the integral of, let's not forget, I keep forgetting the s part, the polynomial, x squared plus x, and then we have plus 2x over x minus 1 dx, and I want to show you a dirty trick here, okay? The integral of 2x over x minus 1 is not obvious. If it was 2x over x squared minus 1, we have an easy substitution. What I want to do, I'm going to subtract 2 and add 2 here. Okay? Watch me. It will be the integral of x squared plus x. And now I'll do the following. I'm going to subtract 2 and break the fraction. And now add the 2. The reason behind it is the following. Now I have x cubed plus x. 2x minus 2 divided by x minus 1 is simply 2. And here I have 2 over x minus 1 dx. Now each of the 4 parts of the integrand is easily integrated. So we can finish this. This is x squared. I was already thinking about the result. X cubed over 3 plus x squared over 2 plus 2x. And what do we have here? I'm sorry? 2 natural log of the absolute value of x minus 1 plus c.
But couldn't you have just done the 2 in the long division anyways, like at the beginning?
These two?
Still, you have 2x left over, and instead of doing the fraction there, like the rational function there, being 2x over x minus 1, you could have used 2x and ended up with, but it would have been negative 2, I guess.
No,
No, it wouldn't have been positive.
we are stuck with 2x is the remainder, so that's what we're staying with. Anyway, this gives you the flavor of partial fraction. What